Okay, now coming to next topic, which is degree of reaction. Now what is degree of reaction? So as I told you, two types of energies are available, are converted in reaction turbine. One is the kinetic energy and second is the pressure energy. Okay, so what is the degree of reaction means how much part of the pressure energy change takes place inside the runner out of the total energy. That is nothing but degree of reaction. Okay, that means pressure total जो energy change हो रही है, that is at kinetic energy change as well as pressure energy change. Now out of that total energy change, उसमें से pressure energy change का कितना part है, that is nothing but degree of reaction. Getting this not? Okay, so कैसे define कर सकते हैं what is degree of reaction? This is denoted by RD. This is change in pressure energy inside the runner. Change in pressure energy inside runner divided by total change in pressure energy inside the runner. Sorry, total change in energy, not pressure energy. Total change in energy inside the runner. Okay, that means out of this total change in energy, how much part is that of the change in pressure energy? That is nothing but the degree of reaction. Ratio of change in pressure energy inside the runner to the total change in energy inside the runner. Now before actually getting into the degree of reaction, let us first determine how much total change in energy occurs inside the runner. Okay, so the total change in energy or you can call it as work done per unit weight per second. Okay, power we have already determined of this Francis turbine or of reaction turbine. Okay, so this total change in energy is work done per unit weight or per unit weight per second. Okay, suppose we are denoting it by HE. So this will be what? VW1 U1 plus minus VW2 U2 divided by G. Getting this? Now we are considering this figure. This is our inlet velocity triangle. This is the outlet velocity triangle. Obviously this beta 2 is less than 90 degree. Here beta 1 is less than 90 degree. Okay, so for this particular figure, obviously this will be equal to VW1 U1 plus VW2 U2 divided by G. We have already discussed this thing. Okay, now from this figure, okay, now what is this VW1? So from here we can determine the value of this VW1. This VW1 will be equal to U1 plus this distance, which is nothing but VR1 cos of beta 1. VW1 is equal to U1 plus VR1 cos of beta 1. Okay, now further this can be written as U1 plus what is this VR1 cos beta 1. Okay, this can be further written as from Pythagoras theorem, this can be written as under root of VR1 square minus VF1 square. So this will be equal to under root of VR1 square minus VF1 square. Getting this or not? Okay, now further this can be written as this will be U1 plus under root of VR1 square minus, now this VF1 square, applying Pythagoras on this big triangle. Initially we applied it on this small triangle, now we are applying the Pythagoras in the big triangle, and this VF1 square can be written as V1 under root of V1 square plus VW1 square, minus VW1 square, hypotenuse square minus base square. Okay, so this will be under root of VR1 square minus we want to determine VF1 square, so this will be directly V1 square minus VW1 square. Getting this now? Okay, now further this can be written as what? So this will be equal to, this is nothing but VW1, or you can write it as VW1 minus U1 is equal to under root of VR1 square minus V1 square minus VW1 square. Getting this? Now squaring both sides, we will get what? VW1 minus U1 whole square is equal to VR1 square minus V1 square minus VW1 square. Okay, now opening a bracket, we will get what? VW1 square plus U1 square minus 2AB 2VW1 into U1 is equal to VR1 square minus V1 square minus plus VW1 square. Okay, so from here we will get what? VW1. So this VW1 and this VW1 will be cancelled. Okay, this VW1 square and VW1 square will be cancelled. Next, this so this will be equal to VW1 U1. Okay, VW1 U1, this will be equal to 1 by 2 of U1 square minus VR1 square plus V1 square. Okay, taking this 2 VW1 U1 this side and VR1 square minus V1 square this side, we will get what? VW1 U1 is equal to this, half of U1 square minus VR1 square plus V1 square. Getting this or not? Okay, similarly we can determine VW2 U2. Okay, how? Same thing. Now VW2 U2, so for that VW2 will be equal to this VW2. So this can be written as what? Total, which is VR2 cos of beta 2 minus U2, VR2 cos of beta 2 minus U2. Getting this? Further, this VR2 cos of beta 2, it means this distance, this total distance. Okay, what can we write this VR2 cos of beta 2? So this will be equal to under root of VR2 square minus VF2 square. Okay, so this will be under root of VR2 square minus VF2 square minus U2. Clear or not? Okay, now taking this U2 this side, we will get what? VW2 plus U2, and doing square both the sides, we will get what? VR2 square minus VF2 square. Getting this? Okay, now further this VF2 can be opening the bracket, we will get what? VW2 square plus U2 square plus 2U2 VW2 is equal to VR2 square minus, okay, further this VF2. What is this VF2? So this VF2 can be written as under root of V2 square minus VW2 square, or VF2 square will be equal to V2 square minus VW2 square, minus of V2 square minus VW2 square. Simple calculations. Okay, so from here again this VW2 will be cancelled out, and we will get what? From here VW2 U2 will be equal to half of VR2 square minus V2 square minus U2 square. Getting this or not? Okay, now putting both these values in our total energy equation, HE, which is equal to VW1 U1 plus VW2 U2 divided by G. Okay, so we will get what? So this HE will be equal to VW1 U1, which is how much? 1 by 2 into G into U1 square minus VR1 square plus V1 square plus VR2 square minus V2 square minus U2 square. Okay, what we are doing is just adding this and dividing by G. Getting this or not? Okay, so this is HE. Now further this can be rearranged as 1 by 2G. This can be written as U1 square minus U2 square plus VR2 square minus VR1 square plus V1 square minus V2 square. Okay, same thing. Okay, so this HE, this is HE not S2. This HE is equal to 1 by 2G U1 square minus U2 square plus VR2 square minus VR1 square plus V1 square minus V2 square. Okay, this U1 square minus U2 square gives us centrifugal effect. Okay, this gives reaction effect, and this gives impulse effect. Okay, now out of this, only this impulse effect is that of the kinetic energy change. Rest both of these terminologies are because of the pressure energy change. Okay, VR2 square minus VR1 square, this is also because of pressure change, and U1 square, the difference in the velocity of the blade, that is also because of the change in static pressure. Okay, so if I want to determine the change in pressure energy, total change in pressure energy, so out of this total change in pressure energy, this is total change in energy, and out of this total change in energy means just remove this thing and we will get what? Total change in pressure energy. Okay, so we will get what? So this will be equal to 1 by 2G U1 square minus U2 square plus Vr2 square minus Vr1 square. Okay, this is total change in pressure energy. Okay, now what will be the degree of reaction? So this degree of reaction, as we have determined, as we have defined, change in pressure energy inside the runner divided by total change in energy inside the runner. Okay, so this is the change in pressure energy inside the runner. So this will be equal to 1 by 2g, and 1 by 2g will be cancelled from both sides. We will get what? U1 square minus U2 square plus Vr2 square minus Vr1 square divided by U1 square minus U2 square plus Vr2 square minus Vr1 square plus V1 square minus V2 square. That's it. So this is nothing but degree of reaction. Okay, you can directly remember this formula. You don't have to look out for the derivation. I have told you the derivation so that you can remember the formula easily and you can apply the formula very easily. Okay, why? Because once you know that in this derivation, in this formula, this is the only thing which is accounting for the impulse effect, for the kinetic energy change. Rest of the two terms are accounting for the pressure energy change. So once you understand this, once you remember this, then you can directly learn the formula of this degree of reaction, which is change in the pressure energy inside the runner divided by total change in energy inside the runner. So this is nothing but the degree of reaction. Getting this or not? Okay. So now we will solve one question of this degree of reaction. This was asked in GATE 2012. The question says the velocity triangle at the inlet and exit of the rotor of the turbo machine are shown. V denotes the absolute velocity of the fluid, W denotes the relative velocity. That means the relative velocity, we are denoting it by Vr1. Here it will be denoted by W1 and W2. Okay, and U denotes the blade velocity. Subscript 1 and 2 refer to inlet and outlet respectively. If V2 is equal to W1, if V2 is equal to W1 and V1 is equal to W2, then the degree of reaction will be. Okay, so this is the inlet figure. Inlet velocity triangle is this. Okay, W1, V1, U, and outlet velocity triangle is this, U, W2 and V2. Okay, and degree of reaction, as I told you, is what? U1 square minus U2 square plus Vr2 square minus Vr1 square divided by U1 square minus U2 square plus Vr2 square minus Vr1 square plus V1 square minus V2 square. Getting this or not? Okay, now out of this you can see one thing, that U is common for both. That means U1 is equal to U2. That means this term will be cancelled out here. Next, Vr2 is represented by W2, Vr1 is represented by W1. So this will be equal to W2 square minus W1 square upon W2 square minus W1 square plus V1 square minus V2 square. Now further, this V2 can be written as W1 and V1 can be written as W2. So this will be W2 square minus W1 square divided by W2 square minus W1 square plus V1 is equal to W2. W2 square minus W1 square. Okay, so this will be equal to 2 times of W2 square minus W1 square. So this degree of reaction will be equal to 1 by 2 or 0.5. Okay, answer should be C. Getting this now? Okay, so this is how we can solve the questions of this degree of reaction. Clear? Okay, now, okay, next is a very small topic, Buckingham pi theorem. कभी कभी इसमें से क्वेश्चंस आ जाते हैं, so we are dealing with it. This is actually part of dimensional analysis. Okay, now what is this Buckingham pi theorem? So what does this say? If there are n variables in a dimensionally homogeneous equation, and if these variables contain m primary dimensions, then the variable can be grouped into n minus m non-dimensional parameters. These non-dimensional groups are called as pi terms. I am sure कि ये समझ में नहीं आया होगा. I will explain you. Okay, so Buckingham pi theorem क्या बोलता है? Suppose we are having, suppose the n number of variables. Okay, total number of variables is suppose n, which may include the dependent variable as well as independent variable, and out of which we are having m number of primary dimensions. Primary dimensions generally are 3, m, l and t. इसलिए हम generally जो dimensional formula में represent करते हैं, that is in the form of mlt. Okay, so primary dimensions are generally 3. So what it is saying, that then the total variable can be grouped into n minus m non-dimensional parameter. Okay, n minus m non-dimensional parameter में हम उसको group कर सकते हैं, and those non-dimensional parameters are called as pi terms. Okay, हो सकता है अभी भी उतना समझ में ना आया हो, but with जैसे जैसे मैं इसको आगे समझाऊंगा और एक क्वेश्चन जब हम सॉल्व करेंगे इट विल बी वेरी क्लियर टू यू, और फिर उसके बाद मैं फिर से डेफिनेशन में आऊँगा एंड देन आई विल टेल यू दैट व्हाट इज दिस डेफिनेशन इज सेइंग. Okay, so what Buckingham is saying, that total number of pi terms we will start from here. Total number of pi terms is equal to total number of variables minus fundamental variables, or you can call it as primary variable. Okay, total number of variable is, let's suppose, n, and fundamental variable is, let's suppose, m. Then total number of pi term is a non-dimensional term, so this total number of pi term is equal to n minus m. Okay, now further this total variable can be either dependent variable or it can be independent variable. Okay, dependent variable means the variable which is depending upon other variables, that is dependent variable, and the variable which does not depend on any other variable is independent variable. I will tell you with the help of one example. Suppose we are having a pipe in which the water is flowing. Okay, so from this pipe the water is flowing. Okay, now what are the variables which are included in this flowing of water through the pipe? The very first variable is the diameter, d, diameter of the pipe. Okay, second variable can be the length, total length of the pipe. This is another variable. Okay, third variable can be pressure. Fourth variable can be velocity. Fifth variable can be viscosity of the fluid or water. And sixth can be the density of water, which is rho. Okay, so these are all variables involved in this flowing of fluid through this pipe. Getting this? Okay, now out of all these variables, the dependent variable is this pressure. Okay, this pressure is dependent on velocity, this pressure is dependent on viscosity, and this is also dependent on density. Okay, so this pressure is a dependent variable and rest of the variables are the independent variables. Okay, and fundamental variable, as I told you, fundamental variable are 3, which is m, l, t. Okay, these are 3 fundamental variable. Okay, so what will be the total number of pi terms here? So total number of pi terms will be equal to, total variable is how much? 1, 2, 3, 4, 5, 6 variables, and out of which we are having 3 variable as fundamental variables, so this total number of pi term will be 3. Getting this? Okay, so this is how we can determine how many non-dimensional variable can be made out of this total number of variables. These are that means pi term means the non-dimensional term in which this all the variables can be grouped. Okay, now how it is grouped और किस तरीके से वो काम करता है, I will explain you with the help of one question, and with this question I am sure कि ये चीज़ पूरी तरह से clear हो जाएगी. Okay, now this is the question. The resulting force F of a supersonic plane during flight can be considered as dependent upon upon the length of the aircraft, velocity v, air viscosity mu, density rho, and bulk modulus of air k. Express the functional relationship between these variables and the resisting force. Getting this? Okay, so क्या दिया हुआ है? The resisting force is dependent of the supersonic plane is dependent on all these variables. What we have to do is we have to establish the functional relationship. Okay, given बस इतना है कि ये इस पे depend करता है. Now what is the functional relationship that is not given, that we have to determine, that we can determine with the help of this Buckingham pi theorem. Okay, now how to solve such questions? Okay, so what it is said, that the resulting force, the resisting force F is a function of, it is dependent upon, first is the length of the aircraft, second velocity, then viscosity, then air density, and then bulk modulus of air k. Getting this? That means how many variables are there? 5 variables plus 1, 6 variables. Total number of variable is 6. That means n is equal to 6, and fundamental variable m is, as we know, is 3. Okay, so total number of pi terms. How many pi terms can be formed from here? So this will be equal to 6 minus 3, which is equal to 3. That means 3 pi terms can be formed. Okay, and for forming this pi term, the very first thing is to determine the repeated variable. Okay, what are the repeated variables? So to determine the repeated variable, I will tell you the easiest process. The very first variable, take first variable as geometric property. Sorry, first will be the geometric property, second will be the flow property, and third will be the fluid property. Okay, geometric property means the length of the pipe, the diameter of the pipe, these all are geometric property. Flow property means velocity of the air or fluid, acceleration of the fluid is flow property. Fluid property means the density, the viscosity, these are fluid property. Okay, so we have to take form 3 pi terms, and the repeated variable will be one of the geometric property, second will be the flow property, and third will be the fluid property. Okay, so how to form this pi terms? So the very first pi term, pi 1, okay, this will be equal to, now first is the geometric variable which is length here. Okay, so this will be L to the power a1. Okay, second is the flow property which is velocity v to the power b1, and third is fluid property which is, we are taking it as suppose we are taking as density, you can take viscosity also, rho to the power c1. Getting this? Okay, into f, the fourth variable which is f. Getting this or not? Okay, now further this can be written as, so the dimensional formula as we know for all these is, this pi is a dimensionless quantity, so this can be written as m naught L naught T naught. This is equal to, the dimensional formula for length is L to the power a1, for v meter per second LT minus 1 to the power b1, for C which is density, so for density kg per meter cube ml minus 3 to the power c1, and next is F, force, which is mlt minus 2. Okay, so these are the dimensional formulas. Getting this? Okay, now equating the terms, for m, l and t, so what we will get is, for this m, the only term, the two terms are there, that means c1 and 1, so equating the terms we will get what, c1 plus 1 is equal to 0. Getting this? Okay, next for L, a minus a plus b1 minus 3c1. Okay, next equating the powers of L. Okay, so equating powers of L, this will be a1 plus b1 minus 3c1 plus 1, this will be equal to 0. Okay, and third, equating the powers of t, we will get what, minus b1 minus 2c1 is equal to 0. Okay, so we have three variables and three equation, a1, b1 and c1. So from here we can determine the value of this a1, b1 and c1. Okay, so from here this I will directly write this value. So c1 will be equal to minus 1, b1 will be equal to minus 2, and a1 will be equal to minus 2. Okay, so from here we can determine this pi 1, which will be equal to L raised power minus 2, okay, v minus 2, t, rho minus 1 into f. Okay, so this is how we can form this pi term. L minus 2, v minus 2, rho minus 1, f. Okay, or you can write it as pi 1 is equal to f by L square v square rho. Getting this? Okay, in the same way we will form other pi terms as well, pi 2 and pi 3. Okay, so how to write this pi 2 and pi 3? Now same thing. Similarly, this pi 2 will be equal to L a2 v b2 rho c2 into fifth variable, which is mu. Okay, so this will be m naught L naught T naught is equal to L a2 LT minus 1 b2 and ml minus 3 c2 into ml minus 1 t minus 1. Okay, so same thing, we can determine the value of a2, b2, c2. So from here this c2 will be equal to -1, b2 will be equal to -1, and a2 will be equal to -1. Therefore this pi2 will be equal to l minus 1 v minus 1 rho minus 1 into mu. Okay, or you can say this pi2 will be equal to mu by v rho l. Getting this? Okay, similarly you can determine pi3, third pi term. I will directly write it as this will be equal to k by rho v square. Okay, so these are 3 pi terms, and from these 3 pi terms you can easily determine the functional relationship. Okay, how? This f, as I told you, is a function of, okay, so the very first term was, I will write it here, pi1 was equal to f by l square v square rho. Okay, so from here this f upon l square v square rho is a function of mu by v rho l and k by rho v square. Okay, so this is how we can determine the functional relationship. Okay, however इतना डेप्थ में नहीं पूछता है बकिंघम पाई थ्योरम, बट स्टिल आई हैव एक्सप्लेन यू विद क्वेश्चन. जनरली जो क्वेश्चंस पूछे जाते हैं, दैट इज जस्ट कि दैट हाउ मेनी पाई टर्म्स विल बी फॉर्म, हाउ मेनी नॉन डायमेंशनल टर्म्स विल बी फॉर्म, एंड दैट इज जस्ट n minus n. That is the question generally asked. Okay, but still you should know how we can solve the questions for this Buckingham pi theorem. Getting this?